Hi, my name is John Occhipinti, and I am the father of Natalie Occhipinti. Natalie is in ninth grade at Castellea, and the reason I'm doing this, and it's called a pencast, is to share some of my information on dyslexia. Now, what's interesting is that my family has a history of dyslexia, which is genetically passed down. Actually got diagnosed with dyslexia when I was in high school, and was still able to go to Berkeley and accomplish quite a bit in my life. But having the knowledge about how my brain worked was really critical to me being successful and understanding what was possible. And so what I wanted to do was kind of share some information, and we're learning more and more as we go along, but I wanted to provide Natalie's teachers some ideas on what's happening with Natalie and a dyslexic student in general. So first of all, when we have someone that is thinking, we all actually think in terms of language. And so when we're thinking about a problem or thinking about life in general, we're typically thinking about it in the form of some kind of a language. And that may seem very simple and straightforward, but it's important to understand that when information goes in and out of a brain, it has to get into the form of a phonological code. So language, if you break it down into its basic building blocks, are phonemes, which are basically sounds of letters, and those letters form words, which can be formed into sentences and phrases, which actually help us derive meaning. And so that's fairly straightforward. So we all understand that. What's interesting is that in our brain there is a phonological module that helps us decode and understand. See, I will start with my spelling. I have terrible spelling. You'll find this out as I go along. But there is a module in the brain that is a language module that basically helps determine what is language sound and then help derive meaning from it. So if a person over here is calling out for help, that is actually just a sound wave of a burst of sound. And if it has an exclamation, you might see the sound wave go very high. And when it enters the ear, it's still a sound wave. That sound wave is actually channeled over to this biological system that we have in our brain that recognizes that this is not a tree falling, this is not a door slamming, this is actually a phonetic code that I need to recognize. It turns it into a language that we understand, and then from that we have the meaning of that, which is someone needs help. Now, any human being that has normal circuitry in the brain will learn to understand language and will learn to speak language automatically. It is a gift that is given to us automatically. Now, what's interesting is that when we move from an auditory input into the brain for higher order thinking, and we move to a written page, and that written page has symbols on it. They could be Chinese symbols, or they could be English symbols, or any other language symbols. There is an interim step that has to happen. The eye has to read these symbols and turn them into language or phonetic code that the brain can accept, and that where we can use our biological gift of God. So to do this is a separate processing unit where information actually has to be decoded. And so we have to convert symbols into sound structure that could be understood by the brain. Fairly straightforward. The thing to recognize is that this is a man-made creation. This is something that has to be learned, and it's not a natural genetic piece of our brain that just inherent. Even though history has been around for a while, not everybody reads, and not everybody has been reading for millions and millions of years. So what is interesting is that in a dyslexic student, and specifically Natalie, this new processor or decoder is handicapped. It's not as efficient as other folks. And so when we have the concept of reading, let me get my language, my dyslexia will come out here. There's two major components. A large component is, or a smaller component is decoding, and another component is comprehension. And the associated language systems associated with comprehension really have to do with discourse, syntax, semantics. These all impact comprehension. And then there's phonology, that is the language system that helps us understand decoding. So if we look at this, you have a text that has to be decoded, and then that helps with word identification. But to get meaning out of a reading, we have to understand there's general intelligence that comes into play. There's vocabulary that comes into play. There's general reasoning that comes into play, and then there's concept formation. The important point is that even though this process is challenged, all of these other things really can remain intact, which means that, and this is what they found, is that there are some phenomenal dyslexic folks in the world that have imaginative creativity. They have extreme intelligence, but they have a problem of just processing the information in. Actually, some experts believe that students that have a super fast processor may actually think that they're smarter than they are because they're getting the information in so quickly, they can memorize things so quickly. Their vocabulary still may lack, or their reasoning skills or concept formation skills and some of the other skills may not really be challenged as much because they can just memorize. And I think that's what the root of many educators are trying to get students to understand core concepts, not just memorization. Well, the challenge for a dyslexic student is they're really challenged to do memorization. So in order for them to learn, they really have to be able to get to the higher order thinking in other ways through multi-stimulus ways. What's also interesting is that what we found through the testing and the IQ testing that Natalie went through, she did a full battery of tests. They found that her higher order conceptual thinking and critical thinking skills were extremely high. They're in the 95th percentile. But when it came to time tests and performing a very quick recall of information or trying to read things very quickly and get concepts out, it was much, much more challenging for her. She was in the 11th percentile. So now I'm kind of moving on to what are the recommendations, and quite frankly, we're trying to learn more and more creative ways in which Natalie can compensate for some of the decoding challenges that she has. And in math, what the experts really recommend is the importance of just giving a dyslexic student more time so that they can process things and get them slow. It may be slower to get them in, but they can get the higher order thinking working once they can get the instructions read.